In the summer of 1908, an unusual event occurred in the region of the Podkamenia Tunguska, one of the largest tributaries of the Yenisei River. Newspapers around the world reported on it, and even more than a century later, it remains one of history's greatest mysteries. On the morning of June 30th, around 7 a.m., local residents witnessed a dazzlingly bright object streaking across the sky from the southeast to the northwest. Its glow was visible for hundreds of kilometers, leaving behind a dense dust trail that lingered for hours. Soon after, a powerful explosion erupted, heard thousands of kilometers away. The ground shook, toppling buildings, shattering windows, and knocking household items off shelves. The shockwave threw people and animals off their feet. Seismographs in Irkutsk and Western Europe recorded the tremors, while Siberian meteorological stations detected dramatic air pressure fluctuations caused by the blast wave. The world was in shock. What had happened? Were aliens visiting from outer space? Had the War of the Worlds begun? Fortunately, there were no human casualties. The Evenki nomads, living relatively close to the explosion site, escaped with only a fright. However, in several villages, homes were destroyed, forest fires erupted, and thousands of animals perished. The explosion's sheer force was evident from the shockwave, which was so powerful that ground tremors were recorded in the most remote corners of the Earth. In later years, scientists gave lectures, books were written, and documentaries were made about this extraordinary event. In 1975, scientist G.I. Petrov determined that the Tunguska object was extremely porous and no more than 10 times denser than the air at Earth's surface. He described it as a loose snowball, with a radius of 300 meters and a density of at least 0.01 g/cm superscript 3. At an altitude of about 10 kilometers, the entire object turned into gas, dispersing in the atmosphere, explaining the unusually bright nights observed across western Siberia and Europe following the celestial visitor's explosion. The resulting shockwave caused widespread devastation in the taiga, but this explanation did not satisfy all scientists. The question remained unanswered. What really happened over Tunguska? Was it a meteorite? An icy asteroid? Did an interplanetary spacecraft carrying nuclear fuel attempt to land? Or was it the detonation of an atomic bomb? Can the truth be determined even after decades? Let's try to reconstruct the events of that distant day. The catastrophe occurred on June 30th, 1908, deep in the Evenki taiga, a remote region rarely visited even by hunters. According to eyewitness accounts, at the moment of the explosion, the sky split open and everything shook from the terrifying impact. Even at a distance of 100 kilometers, people felt an intense heat, as if their clothes had caught fire. Witnesses described seeing a massive fireball appear suddenly on the horizon, transforming into a glowing pillar that stretched up to 20 kilometers into the sky before vanishing within seconds. In the aftermath, a thick plume of smoke rose in the same direction, eventually dispersing into a massive cloud. In 1908, the explosion flattened thousands of square kilometers of forest, igniting a massive fire. One can only imagine the scale of destruction and human casualties if such an explosion had occurred in the heart of Europe. Entire cities could have been wiped off the map, causing irreversible losses to civilization. Modern scientists estimate that the energy released by the Tunguska explosion was equivalent to 1,000 atomic bombs, or a single hydrogen bomb of several dozen megatons. The shockwave devastated an area of 3,885 square kilometers, with trees arranged in a radial pattern across a 60-kilometer-wide circle. These findings only emerged later, in 1927, during an expedition led by L.A. Kulik under the USSR Academy of Sciences. However, as early as 1911, renowned Siberian writer V. Shishkov, working as a railway engineer in the taiga, had discovered a similar flattened forest area to the southeast. This led to a hypothesis suggesting the presence of two separate explosions, or a dual blast originating from the same source. There are numerous hypotheses about the nature of the Tunguska meteorite. Many years have passed since the event, yet a complete explanation remains elusive. The abundance of unexplained details continues to attract a wide range of people to the investigation of the Tunguska phenomenon, from professional scientists to amateur enthusiasts. Over time, And with new scientific discoveries, additional theories have emerged alongside older ones, which suggested it was a crashed alien spaceship, a comet, or even a nuclear explosion. The newer hypotheses propose possibilities such as a black hole, a plasma burst from the sun, a fragment of antimatter, or even a laser beam originating from the Cygnus constellation. Each theory is backed by its own arguments and evidence. Yet, despite the widespread habit of calling the Tunguska visitor a meteorite, only one researcher, L.A. Kulik, the first major investigator of the disaster, firmly adhered to this interpretation. Most modern scientists believe that on the morning of June 30th, 1908, our planet collided with a comet. However, even this widely accepted theory remains speculative. No trace of cosmic material has ever been conclusively identified as a fragment of the Tunguska object. Every summer, around a dozen expeditions set out into the Evenki taiga, retracing the steps of past explorers in search of answers. And every autumn, they return. Once again, empty-handed. The nature of meteorites is well understood today. Until recently, they were classified into three main types: iron, and stony meteorites. These celestial fragments range in size from a few millimeters to several meters. The largest known meteorite, the Goba iron meteorite, was discovered in southwest Africa and weighed an astonishing 60 tons. Every year, at least 1,000 meteorites fall to Earth. Their behavior upon impact is also well documented. They penetrate the planet's atmosphere and crash into the surface, often forming craters. However, the Tunguska cosmic object behaved differently. It disintegrated at an altitude of approximately 5 to 10 kilometers, where it triggered a massive mid-air explosion. The energy release closely resembled that of a nuclear detonation. Furthermore, the Tunguska phenomenon had a complex nature. Starting in late June, the Earth's atmosphere exhibited unusual optical effects. The night sky glowed, and high-altitude luminous clouds appeared. Vividly colored auroras were observed, and the explosion caused a powerful geomagnetic storm that lasted for about 4 hours. In the disaster zone, scientists later recorded a significant increase in mutation rates among plants and some animals. Additionally, 7 different types of cosmic material were discovered in the region. Despite the striking similarities to a nuclear explosion, this theory is contradicted by a key detail: the duration of the event. A nuclear blast occurs within millionths of a second, while the destruction of the Tunguska object lasted about a full second, far longer than any known nuclear detonation. This discrepancy challenges the idea that the event was caused by an extraterrestrial technological object. In 1986, Halley's comet made a close approach to Earth, providing scientists with a unique opportunity to study its composition using space probes. The data they transmitted revealed striking similarities between the chemical makeup of the comet's nucleus and that of the Tunguska object. However, definitive conclusions remain elusive. The Tunguska disaster site contains a vast array of cosmic material, but determining whether any of it actually belongs to the meteorite is nearly impossible. This discovery reignited Soviet scientific interest in the Tunguska event. But can anyone guarantee that the 7 types of cosmic substances found in the region are truly linked to the explosion? Given that meteor showers are a common phenomenon, Earth's surface is continuously bombarded with tons of extraterrestrial material every year, making it difficult to pinpoint the exact origin of the fragments. Scientists did find traces of cosmic material within peat layers dating back to 1908. Yet there is no absolute certainty that these remnants belong to the Tunguska object. Nevertheless, based on the collected data, one conclusion is clear. The catastrophe was caused by a cosmic body that exploded at an altitude of approximately 10 kilometers, unleashing energy equivalent to a 10-megaton hydrogen bomb. However, the exact nature of the nuclear processes involved, as well as the precise identity of the Tunguska object, remains a topic of debate among researchers. To this day, no definitive answer has been reached.